Another type of research that we want to talk about is correlational research. So what is correlational research? This is research that's going to be looking for an association between two or more measured variables. So same as with our descriptive research, we're still only looking at measured variables, but correlational research is going to go a step ahead and start looking for associations, start looking for relationships between those variables. At its simplest form for correlational research, you would start with your first variable, maybe variable x. You're going to measure that variable. The next thing you're going to do is find variable y, your second variable. You're going to measure that. And then you're going to use statistics to determine whether x and y are related to each other. Are they associated? And I have at the bottom here in bold that we need to keep in mind that correlation does not equal causation. Now, what does that phrase mean? If you've dabbled in the sciences before, you may already be familiar with this mantra. You may have seen it displayed in professors' offices or on someone's Twitter feed. This statement is everywhere in the sciences, but people don't tend to explain it to you. But that's what we're going to do here. This is simply a reminder of the limitations of correlational research. Just because you find an association, just because there's a relationship between two variables, it doesn't mean that you can infer causality. You can't infer or assume that you know what the nature of that relationship is. In plain English, just because you know that variable x and variable y are related, you can't say that you know x causes y. And this is a big thing because a lot of media, a lot of news resources that you'll see where they talk about different research studies, a lot of stuff especially that says, oh, eating butter causes cancer. That's usually based on correlational research. And that statement that one variable, eating butter, causes another variable, cancer, it isn't really founded based on the research. And we're going to talk about why. So let's look at the options using an example. So let's look at people who have better social relationships or worse social relationships. We're going to measure them on the quality of their social relationships. And we're also going to look at their happiness. Are they more or less happy? And so if we run a correlation on our two measures, relationship quality and happiness, maybe we find a relationship between social relationships and happiness. And we would say that people who are in better social relationships also tend to be happier. There's a relationship between those. There's an association there. That's what A is showing us, that there's something going on and X and Y are related. But we run into what the textbook calls a bidirectionality problem, which is basically saying that this relationship could be in either of the two directions. Maybe people who are in better social relationships are happier because those social relationships make them happy. Or maybe people who are happy are in better relationships because people who are happy are better to be around and more people want to be friends with them. So which is causing the other? Are people having good relationships and that's causing them to become happier? Or are people happy and that's causing them to have better social relationships? We can't tell from a correlation because our correlation isn't giving us the method of actually figuring out a causal relationship. We don't know which is causing the other. And we can even have another option. This is the big one. This is called the third variable problem. And this is basically the idea that, X might be causing Y, or Y might be causing X, but maybe there's some third variable, something else that we haven't measured, that's actually causing both X and Y. So in this situation, we propose variable Z. So your personality style. So maybe people who are A particular personality type, maybe people who are overly outgoing, tend to have better relationships because they're outgoing. And they also tend to be happier because they're outgoing. So if somebody is more outgoing, they have both better relationships and more happiness. And if someone is not outgoing, they have worse relationships and less happiness. And so there's no actual direct relationship between X and Y. Both are being caused by Z, a third variable that we weren't really considering. So this is just a theoretical explanation that something else could be going on that we're not looking into. So multiple reasons why we can't assume we know the cause. We can't assume that we know the direction of this relationship. And so in our usual pattern, we're going to actually start talking about closer to the statistics side of this, and what would it actually be to have different kinds of correlations? What would we be looking at if we were looking at actual data, if there was an actual study that was giving us a correlation? What would we be looking at and what would it mean? So let's start with the different types of correlations and how we would measure that. So the first thing we need to know is that you're usually going to see what's called a correlation coefficient, usually denoted as R. And different people will use different measures, but this one's fairly common. And this correlation coefficient R is going to describe the relationship between two variables. And R is going to exist somewhere between -1 and +1. So you can have an R that is -1 all the way up to +1 and anywhere in between. And these signs, minus or positive, is going to indicate the direction of the relationship. It's going to indicate if it's a negative or a positive relationship. And the absolute value is going to indicate strength. So the closer to 1, the bigger the number is in the absolute terms, the stronger the relationship. The smaller the value, the closer to 0 it is, the weaker the relationship. And we'll walk through a bunch of examples to try and make this a little bit clearer. So for a positive correlation, we'd be seeing something where an increase in one variable relates to an increase in the other. So the more birds that I have, the happier I feel. And our R should be larger than 0 and in the positive direction. So we'll see that 0 means that there's no correlation, but anything in this range on our scale, larger than 0 all the way up to our maximum of +1, that's going to be a positive correlation. And like we said, the closer to 1 we get, the stronger the correlation. So if we had an R of +1, we have a very strong positive correlation. We have an R of 0.01 somewhere in here, then we still have a positive correlation, but it's a weak correlation. And we can have the opposite. Negative correlation is going to say that an increase in one variable relates to a decrease in the other. So the more work that I have, the less happy I am. And as you can imagine, your R value is going to be smaller, or it's going to be non-zero and somewhere in the negative range. So somewhere between -1 all the way up to, but not including 0. So if you have a -1 as your R, you have a very strong negative correlation. And if you have a -0.1, then you have a weak negative correlation. Both are negative, and then the absolute magnitude, how close it is to 1 versus 0, gives us how strong of a relationship it is. And I've already kind of dropped this one already, but if you have a 0 correlation, if you have an R of 0, there is no relationship. So the two variables aren't related to each other. They aren't correlated with one another. And what does this look like in terms of data? So we still have our scale at the bottom here, but we can look at some scatter plots showing a positive zero, or negative correlation. And so our first one, we have our variable x, the first thing we want to measure. Here they're using hours of studying. On the y-axis, we have variable y, which would be grade point, so what score did you get? So this is saying that the more you study, the higher your grade. So this is a positive correlation. So you can see this upward and to the right pattern. We're going to look at the negative correlation next, because that one's a little bit easier to visualize here. So if we have variable x this time is hours of TV watched instead of studying. So how much TV you watch versus the grade that you get. And in this case, we see a pattern that's moving down and to the right. So the more TV you watch, the worse your grade is going to be. Or the people who have really high grades tend also to not watch, they tend not to watch a lot of TV, because I don't want to start inferring causation here. But we see that there's a negative pattern. And then if we look at a zero correlation where there is no relationship, this is where we have our grade graphed against the number of apples people eat. And so here, there isn't really a clear line that shows either direction. We could kind of put an arrow anywhere, and it doesn't really describe that cluster of points. So this one doesn't get a line, and it doesn't have a correlation. So a nice, easy way to look at those. And if we wanted to look at scatter plots with more data and start looking at intensity or strength of the relationship, all of these are going to be positive correlations, except for our zero here. But if we look, you can kind of squint at this graph here and see that there's kind of a positive trend. And as you move over, it gets clearer and clearer where the larger our R value here, so this is an R of 0.90, that's very close to 1, that's going to be a very strong positive correlation. So we're seeing that a smaller R gives us more spread out data. We're seeing more variability in our data, but it's still a positive relationship because we're still in the positive numbers, even though they're not actually giving us that plus over here. You assume positive when they don't tell you. And we can look at even larger collections of data, and this here is to show you that in order to have a positive relationship, to have an R of 1, it doesn't necessarily have to be this exactly perfect corner-to-corner line. So sometimes we're going to see that, and it's going to look really nice and clean like that, but depending on the scales on your x and y axis, you might have a shallower line. The slope might be a little bit different, but it's still going to be an R of 1. And so here we see a very steep slope, R of 1, a very, very shallow slope, still an R of 1. This one is going to be an R of 0 because even though they're in a straight line, it's still neither positive or negative. And then we can go into our negatives and show that downward slope that is more or less steep depending on the slopes there, but our R value is still always 1 because the data points line up in a nice straight line. And we can look at this middle line here that's just showing us spread. So if we have an R of 0.8, our data is only a little bit spread out. An R of 0.4 is a lot more spread out. 0 is no relationship, so it's just a circle of data points, and so on. So lots of examples to look at here for what we're seeing in these scatter plots and what it means in terms of correlations. And so, of course, we're going to talk about our advantages and disadvantages of correlational research. Some of our positives here are that correlational research can give us an indication of the strength of relationships that we can see right now. So, are people who watch more TV more likely to also have poorer grades? And how strong of a relationship is it? Is it a negative relationship, a positive relationship, and how strong? So we can observe things that are happening sort of presently. The cool part, the part that I really like about correlation, is that you can use the research to make predictions using the data that you have. So you can measure something that is currently happening, and you could extrapolate. You could make some assumptions about past and future data. So maybe in your variables, you wanted to look at time, maybe how much people watch TV at a particular age. So you could look at, if you can measure people between the ages of 20 and 40, and you get a nice straight line that says as they get older, they watch more TV, but the last point that you can measure is right here at 40, but maybe you want to make a best guess. You want to extrapolate and guess how much TV people would watch at 45. So you could extend that line that we calculated and give a best guess about what we think somebody who's 50 would watch in terms of TV. And you can extrapolate backwards as well and get a prediction for past, but you can make use of this data to start making predictions and educated guesses. And another really cool part about correlational research is that it can be used as a stepping stone for experimental research. So maybe you want to figure out what's causing students to do poorly in school, and you're fairly sure that it has something to do with a new teaching strategy, but you're not sure, and you don't quite know where to start. So you could run a correlational study. You could look at teaching strategy versus performance to see if that's even somewhere to start looking. And then once you've established that, yeah, there is a relationship between X and Y, maybe now you want to design an experiment. Now that you've done some groundwork, you're willing to put all of that extra time and effort into designing and executing an experiment. So it gives you something to move forward on. Or maybe you do your correlation and you find out that X is not related to Y. And then you're glad that you didn't try and set up an experiment to figure out what was causing that relationship. So a good stepping stone to get into other research. And of course, there are also disadvantages with correlations. The obvious one, you can't assume a cause and effect relationship exists. We don't get causality from a correlational study. You have to keep in mind that there might be a third unmeasured variable. We're not controlling for a lot of things. We're not manipulating anything. So we have to keep in mind these limitations. And always, it's an association, not a cause.